Here I introduce the VorterantQ. The VorterantQ pump is a positive displacement pump. The four rotors, printed in yellow, have a twisted shape, as if a lens-shaped cross-section were gradually rotating along the axis. A sealed volume is formed at the center, enclosed by these four rotors. You can see that the rotors are in contact with each other, leaving no passage between them. When the square casing, also twisted, printed in blue, is rotated, the four rotors spin in the same direction at the same speed. Can you see how the sealed volume at the center travels along the rotational axis as they turn? This motion pushes the fluid contained inside, making it work as a pump. As you can see here, the cross-section of each rotor is formed by two quarter-circle arcs joined together. The square casing is tangent to this circle. Rotating the casing by 45 degrees turns the rotors by 90 degrees, bringing the rotor tips together at the center and closing off the passage. When the rotors spin continuously, their twisted shape causes this closed region to travel progressively along the rotational axis. Thanks to the twisted shape of the casing, the transmission of rotational force from the casing to the rotors also proceeds without interruption. To achieve smooth rotation, a certain amount of clearance between the rotors is necessary. As a result, fluid inside the rotors gradually leaks into the space between the rotors and the casing. In this model, windows are cut into the casing walls to make the interior visible, but in a real application, the casing walls would be fully enclosed to prevent leaked fluid from escaping. To keep this model compact, the rotors here have been cut short. But keep in mind that, in practical use, the rotors need to be long enough to properly seal the central volume at both ends. This is a model with the casing removed, leaving the rotors exposed. In fact, even without the casing, rotating just one rotor transmits motion to the other three. Without the casing, the rotor geometry is much easier to recognize. Can you see how each rotor transmits force to its neighbor? The rotation is transmitted by each rotor pushing against the side of the adjacent rotor in the axial direction. One proposed way of using the VorterantQ pump is to submerge the bare rotors directly in the liquid to be pumped and drive them while immersed. In that configuration, no specially shaped casing is required, and the problem of fluid accumulating between the rotors and the casing wall and being churned to generate friction losses is eliminated. This pump has not yet seen widespread practical use, but you will find a good way to use it, won't you?